right, the next section we're going to talk about some technical terms that are used frequently in our industry and in our business. This particular segment is going to be the most boring, maybe the most hard to swallow because it's full of technical terms that I'm going to try and make as simple as possible. But I promise if you can make it through this, the rest of it's going to be a piece of cake. So we're going to start with some TLAs, three-letter acronyms, and OPTs, other pertinent terms. So OPT isn't a real thing. I just made that up because I thought it was kind of clever. So don't say OPT to anybody because it's not real. So let's start with who are we in this particular industry. We are EDA. That stands for Electronic Design Automation. And let me pick that apart for you. It means we're automating the design of electronics. So we're going to use computers to design all these fantastic things like iPods and cell phones and who knows what. So EDA, Electronic Design Automation, is our industry. We used to call ourselves CAD, Computer-Aided Design. So we realized probably like 20 years ago that CAD, Computer-Aided Design, was being used for everything. So office furniture uses computer-aided design. Obviously, automobiles use lots of computer-aided design. I actually had a friend who went to work for a company that used computer-aided design to design tennis shoes. So athletic shoes, all the Nikes and so forth, actually use CAD. So we decided let's call ourselves EDA to distinguish that we are using automation for the design of electronics instead of automating the design of some other type of product. Here's another term that's very, very important that we use all the time in our industry, HDL. It stands for Hardware Description Language. Don't get scared yet. What this is a computer language. It's the way you speak to the computer and say, please help me design a computer chip. So if you're familiar with, this is way before modern PCs, but if you're familiar with the language BASIC, where you would give a command to the computer, print something, read something. This is a computer language that you communicate with, like BASIC. Today we use Windows, but we still do type commands to the computer in specific ways so that the computer can understand what it is we're trying to tell it to do. So it's a hardware description language that simply says to the computer, this is what I want my hardware, my piece of electronics or my computer chip. This is what I want it to look like. This is what I want it to do. And because it's very specialized, we have to use languages that we develop. The computers don't understand English or French. So let me give you some examples of some very popular hardware description languages in our industry. The first one is called VHDL. It stands for VISIC Hardware Description Language, and VISIC stands for Very High Speed Integrated Circuit. And I guarantee that this is not a winning question for Who Wants to Be a Millionaire because most people don't care what VHDL stands for. But anyway, this is just one type of language that was invented so that we can tell computers, please help me design a computer chip. Another one that's very popular is called System Verilog. That's not an acronym. It has special meaning to those of us who are familiar with it. But it's another HDL, another hardware description language. There have been, they call them language wars over the years, where people say VHDL is better. No, System Verilog is better, and back and forth and back and forth. But that's like saying French is better than English. It's not. They do the same thing. They just have different dialects, and people can choose which one they want to use. There are also a couple other ones out there. I'm not going to talk about them today, and if you want to look them up or ask me down below, I'd be happy to tell you about them. The term RTL pops up quite frequently in our business. RTL stands for Register Transfer Level, and we're sounding a little technical here. But what this is simply a subset or a collection of commands, a subset of that language that is more refined and helps us to describe what these computer chips are going to do. As an example, VHDL was invented by the United States government to describe what, say, a whole airplane can do, the shape of the wing and how things are connected in an airplane. So it's a very rich language, and you can talk about all sorts of things. But to use VHDL to design a computer chip, you don't need all the richness of that language. You just need a few of the commands. So we group that into something that we call RTL, and those are the commands that we're going to use to tell the computer, please help me design a computer chip. There's another term that we hear a lot, GDS2. And what this is the physical description of how these little tiny parts are all connected to each other and how they're stacked on top of each other. So it's a specification. I went back to try and find out what does GDS2 really mean. The general consensus was that it stands for Graphical Design Station, which was a product invented by a company that doesn't exist anymore. But there was a line of thinking that said GDS2 didn't stand for anything. They just thought it sounded cool. So if you can find the history and let me know, that would be great. But for now, we're going to say it stands for Graphical Design Station version 2. You're also going to hear a lot this term ASIC. It stands for Application Specific Integrated Circuit. Think of something like this. If I take a computer chip, and it's a very general purpose chip, it might be an Intel microprocessor, I could put it in a microwave oven and say, cook my dinner. Or I could put it in my automobile and say, tell me when I'm backing up if I'm going to run into somebody. So that's a very general purpose type of a chip that can do a lot of different things. If I want to have it so specific that it only does one tiny, tiny function that no other chip can do, then that's going to be very specific to my own application. So let's say I want to make a chip that is going to only tell me when someone walks up to my car and looks in the window. That's going to be application specific because you won't be able to say, stick that in the microwave oven and make my dinner. So ASIC is an application-specific integrated circuit. It's just a particular kind of computer chip for all intents and purposes. You're also going to hear the term FPGA, and I'm going to show you some examples and talk about it in a later video. But it stands for Field-Programmable Gate Array. It's just a special kind of a chip. We also use the word platform in our industry, and it can be kind of confusing because when you think of a platform, it could be something like I'm standing on right now. It could be something that you launch the space shuttle from. It's basically a foundation. But when we talk about a platform, it means a collection of our tools. I'll talk about tools too, so don't get too worried. It's just a collection that works well together. So don't get confused if you hear about an EDA platform. Here's another term in our industry that can be a little bit confusing too, IP. And it's a very, very important term, but it means a lot of different things. You might see IP referring to Internet Protocol, which is all about the internet. That has nothing to do with IP when we use IP in our industry. Instead, IP to us means intellectual property. And there's actually two aspects of intellectual property. So what is intellectual property anyway? It's our ideas, it's our inventions, our creations that come out of our head. And the reason intellectual property is so important is because if someone steals your idea and goes off and makes money, it's not only devastating to your business, but it hurts. And so if you've ever had someone steal your idea, you come up with something that's really great and they go off and do it. It's just a really bad thing. So in our industry, we protect our intellectual property like crazy with legal agreements, and you'll see lawsuits pop up where people are suing each other over patents because intellectual property is really, really important to us. Our company has thousands of people, we have desks, we have computers, but our biggest asset are the minds that work here, and that's why we protect our intellectual property. The second thing that I was going to tell you about intellectual property, it also means designs, chip designs. And so if I come up with this brilliant idea for a chip design, I want to protect that. But I also want to be able to reuse it so I can build bigger things on top of it. So later on in the video series, we'll talk a little bit more about IP. But to us, IP also means a little building block, like a little tiny chip design that I can use over and over and build upon. So IP is a very, very important term in our industry. So I promised you I'd tell you what a semiconductor was. Semiconductor, let me take this word apart for you. Semi meaning partial, and conductor meaning a conductor of electricity. So what these semiconductors do is some of the time they let electricity go through and sometimes they block it. So pretty simple term when you look at partial conductor of electricity. In our industry, we affectionately call it an integrated circuit, IC, or simply a chip. And when I say a chip, I don't mean a cow chip or a potato chip or a chocolate chip, or as one of my dear friends, Ed, says, it's not a poker chip either. And if you don't know what a cow chip is, I'm not going to put it on the video, but I'd be happy to tell you about cow chips if you are elsewhere in the world than the Midwest. But I do have an interesting quote, too. Now, although this gentleman denies saying this, Michael J. Boskin, who was chairman of President Bush's Council of Economic Advisors, and this is George H. Bush, not George W. Bush. So this guy, he's on the President's Council of Economic Advisors. He will, again, he denies it, but he will go down in history as the man who said, it doesn't make any difference whether a country makes potato chips or computer chips? Now imagine the computer chip industry in an uproar over a statement like this, because actually it makes a big difference when we produce computer chips. They're a lot more high-tech than a potato chip, and you're about to see some more as we continue.